Well, we're just flying through this year and we're ready to start a new topic called exponential functions. So let's go ahead and title that nicely in our notebook, Intro to Exponential Functions. So you're probably thinking, what is exponential? I might have heard that word before. And here's our definition. So again, let's get this nicely in our notebook. Exponential functions are functions whose exponent is a variable. And that's the whole key to recognizing an exponential function. Its exponent is a variable. The next thing we want to neatly star in our notebook here, and we can put it in a nice box, is our basic, example of an exponential function. And that is y equals b to the x power, where b is greater than 0 and b cannot equal 1. Okay, now notice this is called exponential because its exponent is a variable. The exponent is x. Therefore, it's automatically going to fall under the exponential category. And here's the guidelines is just this number, our base. Okay, that b again is called a base. The x is called the exponent. That base has to be a number bigger than 0 but not 1. Now you might be thinking, okay, 2, 3, 4, 5, 6, etc. But don't forget you could use like 1/2, 3/4, etc. It just has to be bigger than 0. So example 1, we're going to start off with some graphing. Now if you've purchased the graph paper from us, those mini sticky sheets, feel free to grab that and we'll use that nice and neatly. If not, feel free to come ask us and then we have them for $1.50 there. Otherwise, you're going to sketch a really neat one on your own in your notebook. So exercise 1, consider the function y equals 2 to the x. Fill in the table without using your calculator and then sketch the graph on the grid below. Okay, so no calculator. All right, so all I'm going to do is I'm going to say, let's start with the easy one, 2 to the 3rd power. And we all know that by now is 8. If we didn't know it, it's just 2 times 2 times 2. 2, replace the x with a 2. 2 squared is 4. 2 to the 1st is just 2. 2 to the 0. All right, there's an exponent rule we've talked about. Anybody to the 0 is 1. 2 to the negative 1. All right, now don't tell me it's a negative answer. Remember, negative exponents just move you to the bottom. 2 to the negative 1 is really 1 over 2. 2 to the negative 2. Again, no calculator. Okay, if the negative wasn't there, 2 squared is 4, and the negative puts you on the bottom, so 1/4. Oops. 2 to the negative 3. Again, if the negative isn't there, 2 cubed is 8. The negative, puts you on the bottom, so 1/8. Now we want to neatly sketch those, and again, I'm going to start with the easy ones. I'm going to start with the nice whole numbers. At 3, I should be at 8, so let's plot that point. And why don't you pause it, and your goal is just to plot all of those points down. So pause it and see if we get the same graph. Okay, now I have my points plotted. I did make one little error, so I just want to cross that off, pretend that's not there. And my goal is to neatly connect these. Now, this graph is going to go up forever, so I want to go right to the end and put an arrow on the end. And then this graph is going to go down forever. Now, there's one little thing that's going to happen. No matter, think about this, if I have 2 to any power, 2 to the negative 5th, let's say. All right, well, if that negative isn't there, that's 32, and that's going to make it 1 over 32. Basically, I'm going to get 1 over 2 to, let's say, the infinity power, any number in the world. It's always going to be a positive number. All right, and that's pretty fascinating. That's telling me this exponential graph is going to lie above the x-axis. Now, it's just going to get infinitely smaller and close to the x-axis. So much if you were to graph it on your calculator, it might look like it touches, but it never touches the x-axis. So what we're going to draw in next is this nice dotted line here, and this is part of your exponential graph, so let's get it in nice and neat. Okay, so again, your calculator wouldn't show this. This is something you have to know on your own. This line is called an asymptote. Okay, we're going to start to use that word a lot coming up. That is an asymptote, and what that means is this graph gets infinitely closer when it comes down this way, but it never touches. It just gets closer and closer. And let's label that asymptote. It crosses the y-axis, and that's the line y equals 0. Let's also label our graph here, y equals 2 to the x. And we've officially drawn our first exponential graph without a calculator. All right, exercise 2. It says now consider the function y equals 1/2 to the x. I just want you to remember that this number here, our b number, just had to be greater than 0, and it could not equal 1, so 1/2 is fair game. Now it says, use your calculator to help you fill in the table. All right, so I just want to be clear, I'm just going to my y equals button, and I am typing 1/2 to the x power. Now let's talk through some tricks. Remember, if you have that updated calculator, you're hitting alpha y equals will get you your fraction tool. If you have the old TI-83 calculator, watch those parentheses, 1/2 parentheses raised to, your exponent goes in parentheses. All right, so let's go ahead and get that typed in, pause it, grab your calculator, and see what you get. So I've got my numbers filled in, and I just want to make sure it makes sense to you because you will have to do this in your head. If I had 1/2 to the -3rd, all right, the first thing I do is I say, okay, this negative turns it into a fraction or flips my fraction. So I'm just going to flip my fraction and say it's 2/1 cubed, and 2 cubed is 8, and 1 cubed is 1, so I get 8. Same idea, 1/2 to the -2. Okay, that negative is going to flip the fraction, so that's 2/1. And now square everybody. On top I get 4/1 is just 4. And you get the idea where those came from. So let's do the same thing. Either pause and sketch a really nice graph or grab your graph paper and let's carefully plot those points. I'm going to go ahead and pause, you do the same, and let's get it sketched. Alright, so again I've got my points plotted. You'll notice this time our function's going down. Okay, again, it can never hit that axis. Let's make sure we go to the end and stick arrows on it. And we also want to draw in what we call the asymptote. Okay, A-S-Y-M-P-T-O-T-E, asymptote. And again, that's the line y equals 0, and this is y equals 1/2 to the x. Okay, so what we're implying with that asymptote is that this graph is getting closer and closer, infinitely small, but never touching. Exercise 3. It says, based on the graphs and behavior you saw in exercise 1 and 2, state the domain and range of each exponential function of the form y equals b to the x. Alright, so here's what I want you to do. In your notebook, I want you to label this exercise 3, and I want you to real quickly, I want you to make a generic x and y axes here and sketch this function in, and let's label it y equals 2 to the x. Make a generic x and y axes, let's just sketching, you don't need graph paper, let's just quickly sketch it, label it y equals 1/2 to the x. And now we really want to focus on the domain and range. So pause it if you need to, and let's get those sketched. Alright, back in business here. Let's talk about the domain of y equals 2 to the x. Now domain, remember, are your x values. This graph goes forever this way, and forever, it's going to keep going up forever, so it's going to go forever this way. So our domain, we can say two things, all real numbers, or negative to positive infinity. Alright, let's talk about range. Range again are my y values. Alright, now clearly the graph goes up forever, but does it go down forever? No, remember we have this asymptote here. It does not touch 0. Okay, it gets closer and closer, but it doesn't touch. So we're going to put an open parenthesis with a 0 to infinity, and that always gets a parenthesis. Or we could say all the y values have to be greater than 0. Okay, now this function also has another name we can describe it as. Remember, you read left to right, okay, right? Things go left to right. Therefore, if you were to walk on this from the left to the right, would you say you are increasing or decreasing if you walk on this function? And again, it's got to go left to right. We would say this function is clearly increasing, all right? And that's when this b is greater than 1. So let's make a note. If b is greater than 1, our function is increasing. Okay, if b is greater than 1, if you were to walk on it from left and right, you're going up, your function is increasing. Alright, let's talk about that second graph we drew. Let's go get its domain. Alright, remember domain are those x values, so if I go left to right, I would say the domain is the same thing, all real numbers, negative to positive infinity, however you want to say it. My range, when I talk y values, again, 0 to infinity, I'm talking the y values, or I could say the y values are greater than 0. Notice we can't say equal to, it doesn't actually hit the asymptote. And now let's describe this function. This b value here, alright, has to fall, we already said it has to fall between 0 and it's going to be less than 1. If that number is between 0 and 1, that tells us our function is decreasing. Okay, and if you're ever confused with the increasing, decreasing, I just imagine walking on it from left to right. This is my left side. If I start on the left and start walking towards the right, I am clearly going down. So that is a decreasing function. All right, so that's something we do want to make sure we understand the difference. If this b value is bigger than 1, you're increasing. If it's between 0 and 1, so if it's some sort of fraction or decimal, you're decreasing. All right, exercise 4. Which of the following exponential functions would increase as x increases? All right, so maybe just look at the notes we just talked about. All right, what does that b value have to be if you are increasing? And here's the deal, guys. It's okay if you forget it for a moment. All you would have to do is graph each of them. All right, I would just go through and quickly graph each of them. But hopefully you know the rule. If the b value is bigger than 1, that tells us our function's increasing. So I just have to say is 2/3 bigger than 1, is 1/2 bigger than 1, 5/4 or 7/8. And hopefully you recognize 5/4 is bigger than 1. All right, moving on. Exercise 5. Now consider the function y equals 7, 3 to the x. All right, so let me just tell you what goes through my head as I read this. The first thing I say is I notice this exponent is a variable. Therefore, this is called exponential. Okay, the exponent is a variable. Then I notice my b value. My b value is greater than 1. So in my head, I'm saying, okay, this picture better increase. It's bigger than 1. So I kind of get a game plan of what I want this picture to look like in my head. All right. Exercise A, determine the y-intercept of this function. All right, so let's make sure you jot down y-intercept on your paper there. And we've talked about this before. Picture this, if you cross the y-axis, okay, just general, anybody that crosses the y-axis, what is 0? Is the x value 0 or the y value? Clearly, the x value is 0. So all I'm going to do is say x equals 0, and I'm going to carefully plug this in. 7 times 3 to the 0. All right, then I'll just say that 0 is strictly sitting on the 3. So 3 to the 0 is 1, anybody to the 0, and 7 times 1 is 7. So I know this graph crosses at, and let's just label it 0, 7. Does the exponential function increase or decrease? Explain your choice. Well, our game plan already told us that our exponential function better be increasing because our b value is greater than 1. Then it says create a rough sketch labeling the y-intercept. All right, so I know exponential increases, so I know it's going to look like this. Now here's the deal. I just got to figure out where my asymptote goes. All these exponentials have one. The asymptote, and let's make another note here under part C, the asymptote is 1 below the y-intercept. Okay, the asymptote sits 1 below the y-intercept. So if my y-intercept is at 7, that means the asymptote is at 6. And let's label that y equals 6. It's always 1 below. All right, exercise 6. Consider the function y equals 1/3 to the x plus 4. Okay. Part A, how does this function's graph compare to that of y equals 1/3 to the x? Now, we've talked about this a lot before, and I'll just kind of make some notes down here. If I said y equals, let's say, x plus 2 squared minus 5, we should know where this shifts our graph. We did a lot of shifting early in the year. We said anybody with the x is a horizontal shift, and anybody outside is a vertical shift. Okay, and that's going to apply to what we do in this next coming units here. So look back at that example. What do you think this plus 4 does to your graph? Do you think it's a horizontal shift or a vertical shift? Hopefully you're saying that plus 4 shifts the graph up 4. That is a nice vertical shift. All right, so how does it compare? Again, I would say a vertical shift up 4. Part B, determine your graph's y-intercept. Okay, and again, if you ever forget, just make a quick sketch. If you have a y-intercept, you cross the y-axis, that means your x value is 0. So I'm just going to carefully plug it in. I got y equals 1/3 to the 0 plus 4. Now remember, anything to the 0 doesn't disappear. It turns into the number 1. And 1 plus 4 is 5. So that means this graph is going to cross at 0, 5. And let's just get that labeled, 0, 5. Create a rough sketch. Now the last thing I need to know is this function increasing or decreasing? And just look at that b value. the b value is between 0 and 1, which tells me that my function should decrease. So here's how I'm going to draw it in. I'm going to start high, going low, decreasing. I want to make sure I draw my asymptote in. If this was at 5, my asymptote should be at y equals 4. Okay, it's always 1 below. And we've got this beautiful decreasing sketch. All right, now to quickly recap, I want to remind you that it's exponential. Okay, I'm going to say y equals b to the x if the exponent is a variable. That's what makes this function exponential. If my b value, I've got two options. If b is greater than 0, but remember it cannot equal 1, then my function is increasing. And again, you should be writing this down as well. This is kind of a quick summary. If my b value falls between 0 and 1, which means it's like a fraction, a 1/2, a 1/3, etc., that tells me my function is decreasing. All right, the last thing we want to start here is the asymptote sits 1 below the y-intercept. Okay, 1 below the y-intercept. And remember that y-intercept just means the x value is 0. And it's easy to, if you forget, you sketch it out. You say, what's special about a y-intercept? Oh, the x value is 0. Well, that does it for us tonight. We just had a nice quick intro to exponential functions, and we look forward to some great practice tomorrow. We'll see you then. Have a great night.